So now we start. So, do we have any developers here? Yay! You know, I usually start all my sessions. I talk a lot about performance and that stuff, you know, that's really important stuff, about having happy customers. I hope you hear me. Do everyone hear me? Yeah? I have this mic thingy as well, and I'm going to be recorded, and that's getting me really, really nervous. I'm really, really nervous now. Yeah, so I usually do these talks for DBAs, database people, those that work with the servers, you know, the thingies that actually run the code that you are producing. I usually start all my sessions with, do you know that 100% of all the performance issues in databases are due to developers? But I will not start like this right now. I would say it like this instead. Do you know that at least 100% of all the performance we gain in SQL Server is due to the DBAs? Okay, I have bad jokes, really bad jokes. Right now they are like totally clean. They might not be clean, and I'm sorry for that. My name is Mattias Lind. I come from a company called Society. I was invited here by Carl-Henrik, who is not here. He's been wanting to have me do this talk for like, yeah, since I met him first time, because I told him that you are doing it wrong. And then he said, yeah, okay, prove it to me, and I proved it to him. And then he wanted, oh, can't you talk to other people about this? So we were trying different platforms, and we ended up with Coding After Work. Yeah, so I've been thinking coding after dark.
Some people actually do.
Yeah, I usually try to code after dark so no one sees me. I'm not here to teach you how to code. I'm not a developer at all. I'm an architect. I usually say that I'm a DBA, and for me the A stands for architect. And that means that I interact with developers as well, and I'd like to interact with you guys here. I'm going to speak in English, if that's okay for you, because at least Bernardo wanted me to speak English. So the minority wins. Minority reports as well, maybe. Who knows? Who knows? So I cannot teach you how to code anything, because you guys are better than me in coding. I'm like a really, really noob in coding. I've been trying to learn C# and that stuff for years. But I tend to focus on the database parts. And the reason behind this session was actually based on a developer evangelist a few years ago. He was calling me and said, hey Mattias, can you help me? We have this really, really bad performance in this application. We are using NHibernate and interacting with the SQL Server, and we are doing this and this and this. Can you do some index tricks to help me solve this issue? And he was doing bulk loading of data through the object relation mapper. So bulk loading of data, that means more than one row. 2 rows is a bulk. Actually, technically it's a bulk, but in reality, 2 rows is not a bulk. But when we are talking about hundreds of thousands of rows loaded into the entity model, and from that logical model, having it persisted in a database, you know, 100,000 lines of code generated 300,000 SQL statements. So I said, yeah, I can probably help you doing the stuff. I can probably half the time of everything, but the only way of solving this is you stop using that logical data model for bulk loading of data. No, it's not bulk loading, it's only 100,000 rows. Yeah, you are creating a client-side cursor. No, it's not client-side cursor, it's a web server. Yeah, but the web server is a client to the database, and you are running this somewhat loop, or for each iteration of data over the network. So I can probably shave half of the time away by doing some index stuff to making all those insert updates and deletes that are occurring going really, really fast. But to solve the issue, we need to rethink the way of loading data instead, and working with procedures. And the guy said, oh, we have made a design decision of not using procedures in our databases. And I said, why? Yeah, because we don't want to have business logic in the data layer. And that's when I realized that I need to do this talk as well. Because procedures is not business logic, it's data logic. You can use procedures to enforce business logic if you want to in a database. I'm the first guy to say that you shouldn't do that, because that's really, really silly, because that actually gives you more problems than benefits. Even if it's awesome to have procedures of 16,000 lines of code or something like that. Have you seen procedures like that? 16,000 lines of code in a procedure is nothing. The biggest procedure I've been working with, it was 72,000 lines of code. It was actually a database that were built on Oracle and then ported over to SQL Server. And they actually reduced the size of the procedure with around 30% when they did the migration. They still had performance issues. But they built a full application with PL/SQL, which is the language of Oracle. When we are talking about Microsoft SQL Server, we are talking about T-SQL or TSQL, Transact SQL. A bit about me. You have my contacts. I have I've been doing stuff for some years. So get down to business. Entity Framework. Have everyone been using Entity Framework in here? Yeah. So everyone has opened up Visual Studio, imported the package, and created a model. Did you do anything more than just creating a model? Yes or no? Yes. So some say yes and some say no. Yeah. So this talk is not about how to configure Entity Framework or do the Visual Studio stuff. I have some slides that has the title Entity Framework, just because I want to have some slides with the title of Entity Framework. If we are looking at the framework today, the latest production version is the 6.1.3. Is that correct? We are having a beta of Entity Framework 7, the update 2 or something, or 1, or whatever, but that's like somewhere in the future. And if you are doing something code-wise and you need to have a database and you want to use an object relation mapper like Entity Framework, don't use the Entity Framework 7 because it's not ready. When we're talking about an object relation mapper, what's the reason why we have an object relation mapper? I'm asking you guys. Why do you want to have an object relation mapper?
Save time.
To?
Save time building up a way of having something sitting on top of the database to deal with updating, inserting.
Yes, save time is one way, yes.
You don't have to interact directly with the SQL. You can have something else do that layer of translation between your model and your software to the database.
Yes, to have an abstraction layer in between, yes. The really cool thing with most of the object relation mappers is that they can support different kinds of databases as well. It doesn't need to be SQL Server. It can be Oracle. It can be MySQL or whatever. And it fixes everything automatically in the behind. And that's beautiful. So have you been working a lot with Entity Framework? And have you been working with the application that interacts with database, and have you had performance issues, for example? Yeah, you are nodding and smiling. I like the smiling part. You can nod as well. Nod the smile. So if everyone is smiling right now, that would be awesome. If you're not smiling, I'm gonna do something silly. I do silly stuff. There's a rule of thumb. If something is done automatically, is it good? If it works, it's good, yeah. Will you have awesome performance and experience with something that is done automatically? Sometimes, yeah. So what I usually say that I totally love this with object relation mappers and having an abstraction layer between the object model and the database. It's perfect to disconnect. But what I'd like to see is that everything that is written in code is disconnected from tables. Because the biggest problem I see is that you build an entity model and then you have a direct replica of an entity to a table. So if you have performance issues like 6 months after the launch, you had that problem before maybe, I'm not sure. That's my biggest business actually. People are calling me in panic, help us. We have these problems. And I said, yeah, you did it wrong. Let's do it right. But it means that we need to change this and this and this and this. Yes, because you did it wrong. Having an entity tied directly to a table and means that if the table has a bad design and you need to redesign the table, you need to rebuild the entity model. And when you are rebuilding the entity model, what do you need to do then? You need to recompile your application. So think about this. If you are doing it right, you can change the data model, the physical data model, without rebuilding your application. Would that be awesome? Yeah, it would. It would be really, really awesome. I'm not going to show you how to install the package because I think you guys do it faster than I do. I have it pre-installed already in my environment. When we're talking about a framework like this, an abstraction layer, we are talking about actually two different layers. We have a model and we have an object layer. And if you're looking at the model layer, it's the conceptual model of the data. So in our application, we are creating classes. So we can create objects, yes, and the objects contain the data that we want to store in an entity. That's correct. That's just a logical model. Then we need to have a physical persistence layer for this. And that's why we have a database. So we have a conceptual, logical model of our data, and then we need to have a physical persistence schema where the data is physically stored. And this can be done automatically by the entity framework when we are configuring the framework. And it also gives us the mapping between the logical and the physical. The good thing with this is if you are just using the logical part of the configuration of your framework, it's totally transparent to whatever data platform you are having, or at least close to every kind of data platform you could use. It works with Microsoft SQL Server, MySQL, Oracle, and so on. Probably a bunch of other databases as well. If we are looking at the object layer, so the object layer is where we interact with the data. So we are running queries to this logical module, and the logical module is understanding what you want to do, and then it generates code to the bottom data layer. And it materializes the data as objects. So every single row is a specific object. And it helps us to track changes to these objects. So when we are changing something, if we are updating a field of an object or a property of an object, it means that it understands that we need to do an update. Or if we are deleting an object, it understands that we need to delete it from the database, and it fixes the underlying code for us. And with this, we can also use this as a model to generate controls and interactions. So we can have this traversing and iterating through these logical data models, like stepping forward, stepping backwards, and so on. We can also, I'm trying to find the right word, having different objects to relate to each other. So if we have a sales system, we can have a table for orders, and then we can have an entity for orders, which has an order row entity, and we can have the method of adding all the rows to an entity, or method of adding orders to an order row. Is that right? Yeah? So you are the developer guys, you know. So this part, I'm like the kid in the room. So if I'm using the wrong words, please correct me. If I'm using the right words, please tell me afterwards that I use the right words. So I'm self-taught in coding. I started to do like Pascal and stuff back in the early 80s. So how many of you were born in the 80s? Yeah, born before the 80s. When I say 80s, it means like 1980 and forward. So if I say 70s, it's like me. I'm a kid from the 70s. I was born in 72. Yeah, feel free to talk. It's cool. Yeah. And when we are building these modules, we have like 3 methods. We can do the database first. It's like if you ask a DBA guy or an Oracle guy. I say DBA and Oracle because I diverse those kind of people. And DBA is more flexible and accepts multiple different data platforms. An Oracle guy only accepts Oracle. They are getting less and less. But we have like database first. This means that we have already had the vision of all the different tables we need and all the columns we need for this application. So we build a database, and then we generate an entity model from it. Yes, that's database first. That's kind of cool, but how many of you have been having the full view of how your database should look like before you started to code? Maybe not many. The other method is like the model first, and that means that you have a guy like me or another guy who call himself an architect and actually have the higher price on the invoice and so on. And he has the vision of everything. So he decides all the logical objects and all the logical model, and then the DBAs and the coders need to just follow the line. Do as I said. Yep. That's model first. That means that you build an entity model first and then you implement objects from it. It's like database first, but in the softer side of the full infrastructure. And then we have code first. This actually is like when you are building your stuff, you are deciding, you are adding or removing or changing the model as you go. And believe it or not, I'm actually loving code first because that's the perfect contract between a developer guy and the database architect. That's the perfect way of a developer describing, this is the data need I have. The problem with the code first is if you are only using code first and changing all the objects, that means that you might have major changes in the data model tomorrow. And if you are doing code first, you need to think about versioning of the database. Like, yeah, we give you free room, do whatever you want with the logical data model until this date. Then we freeze that model. And if you need to have additional attributes for an object, you need to create a new entity for those specific and have a one-to-one relationship in between. Because in that case, we can freeze the architecture and still give you room to be creative. So that's the way of actually having code first to work. I'd say like I probably think it's like this in the reality. Developers, when I talking about those who are the ninjas in code, not those that were the ninjas of code and today is the architects. Yeah, the real developers like code first because it's flexible. And you're not tied into a corner. You can do whatever you want. Good or bad, you are free to do what you need to do. And guys like me usually say, yeah, let's persist the data model first. And when we are saying data model, we are not talking about this flexible kind of loose structure of an entity model. We are talking about the database. And we like to create procedures for everything. And do you guys like procedures? Some not, some do like this. I don't know, what's a procedure? And someone are just smiling. Yeah. So DBAs are like a bit more square in this. Yeah, of course, the database is the most important thing in everything. If life would to start again, the first thing we would build is a database. Yeah, and if we are talking about architects, they like to do this cloudy thingy, creating theoretical models of everything, and then guys like us, both DBAs and developers, actually need to try to understand what the dude actually meant. Yeah, and maybe say like this, yeah, it's not possible to have a relationship on that case because we don't have any attributes between these two objects that actually relate to each other. Yeah. So what I'm going to show you is actually one of the few lines of code that I actually write or been writing. I'm actually been writing a bit more than just this, but it's a really, really simple website where I've used the code first methodology. But I will not do the typing. I will just open up my solution and show you the stuff. It's not really, really fancy. And I'm doing this just to show you what happens beneath the hood. So when you are doing code first, you can have this method of also generating the data model. And depending on what version of Entity Framework you have, you can have these incremental updates as well, or a rebuild all. And that's the challenge with the code first, because if you let Entity Framework actually see that you have changed the data model, so it needs to repropagate, rerun the create statements, you lose all your data. Yeah. And I'm going to show you what we get by basically just creating these classes and nothing more. And then show you just some basic properties to change to get a bit better controlled data model. And then we are going to talk about SQL Server and databases and database modeling and that on. So this is actually a session not about Entity Framework, what happens below Entity Framework. What happens in the database and how should we actually do this? And what is normalization? And what is that most developers say, this is premature optimization and I just call it data modeling and common sense. And why I think it's common sense and how we can, just by thinking a bit more when we are creating our models, how to get a better interaction between the developers and the DBAs and how to get awesome performance in the data layer. And having databases that works, that works. And works even outside of the application. In my reality, when we are creating an application, this application probably need to have a database. Who owns this database? Is it the developers? Is it the application? Or is it the organization? Who owns the database? Option 3, the organization. Usually when we create this database with this application, usually we have the application as the primary consumer of the data today. But tomorrow, we have a huge different set of consuming from this database. We have data warehouses that reads data from these databases. We create reports and so on. We combine data from one database with data from another database for a third application and so on. So actually, the application tomorrow is like secondary or tertiary in consumption of data in the database. Have you thought about it like that before? You are nodding, but have everyone thought it like that? So when I'm creating a database, the database starts to live its own life at the right moment, the first moment when we put it into production. Because as soon as we put the database in production for this application, we get all the other consumptions from this database. And all the other consumptions are probably even more important for the organization itself than the specific application is. And that's how I see it. But I'm just giving you my side of the story and my ideas. I'm not giving you the truth. I'm just giving you some more tools in your toolbox. to think a bit outside of the scope. I'm trying to keep myself within the pillow here so I don't get out of the picture, and it's really, really hard to have this huge stage, you know. I'm a guy who usually walks around everywhere and like this. Yeah, you know, we met before, so I kind of try to move around. So right now I have this square meter. So this is the scary thing for me, showing developers code that I write. Please laugh if you want. It's a really, really advanced application. I'm not going into the details. I'm just jumping to the core. Just trying to find the stuff. This is my model. It's a really, really advanced model. I have this ID, you know, I travel the world, I have a lot of friends, so I need to keep track of my friends. So I created an application called My Friends. I was thinking about, yes, this can be the new Facebook, you know. So I built this application. I'm going to show you the application first, actually. And I realized today that debug the application in Edge sucks. So I'm going to debug it in Internet Explorer. But I need to show you how nice this application. I'm really proud of the aesthetics of it. Yeah, for being a database guy, creating something like this from scratch, isn't that awesome? Yeah, for me it's totally awesome. If you want, I'm going to share the source code with you. You're free to use the source code how much you want, you know. You don't even need to put my name as a tribute on it. You can use it totally free. Yeah, you see, we have these sections here. You have like links to my blog, yeah, and to my employer and to SQL Server. That's the most important thing. The funny thing with Society, I actually started there 1st of April 2 years ago. And it took me like 2 months before I actually believed I was working at Society. Yeah. Yeah. Yeah, the salary were like a joke, you know. No, I'm just kidding there. That's a bad joke. I actually enjoy working for this company. I was my self-employee. First of all, I was working in like small shops around in Dalarna, and then I started to deliver training, and then I decided to do my own shop. So I had my own company for 10 years, and I was totally fed up with it after 10 years because I wanted to have people around me, like colleagues. So I could actually have started like a company like 1337 or something 6-7 years ago, and started to employ ninjas. But I was like, I don't want to leave Dalarna, you know. And 2012 was not the right time to start to invest in employing people. Not if you come from just your own shop and don't have investors, you know. If it's your own personal money that you need to invest in other people, it's like, it's a bit scary. So I moved to a 10-company consulting firm. I stayed there for just about over a year and realized that I need to have a slightly bigger company. So I moved to another consulting company, around 100 people. And I realized that I need to have an even bigger company. So I moved over to Society Capgemini and ended up like one of 180,000 people around the world. Yeah, you are really like the point guy for that company, you know, the front face, or you just disappear in the noise. I try to make a lot of noise. Yeah. The cool thing with the 1st of April 2014 was actually the release date or the global available date of SQL Server 2014. So they released actually SQL Server 2014 in tribute to me joining Society. That's my belief. Yeah. So I have 2 links here. I have the home link, so we can get back to home again and see this beautiful page. You see, I really like to play around with colors and stuff. Yeah. And then we have all my friends. And this is, oh, it works. You see, I have two friends. They are imaginary. Yeah. But I have two friends. And I actually create them every time I rebuild this application. So I don't lose track of them. But this is the full application. And usually when people do stuff like this, they use something really, really awesome and really, really fancy and really, really complex thing to describe something. And spend too much time talking about, oh, I did this and this and this, but that's totally out of concept. So I talk about myself instead to be out of context. I think that's more funny. But we don't need to have a really, really advanced data model to talk about data models. We need to have a model that everyone can understand. And this is really, really easy to understand. How many of you have friends? Can I count you guys as my friends? Oh, at least a few. Thank you. Yeah, so I'm gonna add you guys in here after this talk, you know. Yeah. So this is the full application. I can actually look at the details of a specific person. I can edit that person. And I can do a change on that person and save it. I can actually create new friends. Oh, I can't spell. Oh, it works. Let's see if I can add another one. And I could actually add an object here that actually didn't use all the properties as well. So I might have been doing something wrong. I don't know. But you saw I had an application that actually, and I built this myself. Okay, I used a template, but I did a lot of stuff myself. I don't think I can wow you with my coding. No. So it all comes down to this model and this entity here, because this is the entity, and we see we have 1, 2, 3, 4, 5 properties with data types and names. And when I execute this, I actually get a database called My Friends. It's not version 10, it's actually version 1.0. But I don't like to have string splitters in names. And you see, I got the table as well. I actually got two tables. The first table is really important for Entity Framework. I think it's not that really important, but for Entity Framework, it's really important. And then I got this beautiful little table here with a few columns. And we see that my strings go to nvarchar. You know what nvarchar stands for? It stands for Natural Variable Length Character String. Natural N, it's Unicode, so it supports more than just A to Z, or Ö here in Sweden, and the numbers, and just a limited set of characters like those 255 first ones in the ASCII table. So N means that it actually supports even other characters outside just Swedish. This database has a collation, which probably is the default of the server. And we see it's Finnish Swedish, so it supports all the characters we can have here in Sweden and Finland.
Isn't it a better practice to use ID instead of friend ID?
It depends. I kind of like this ID column is the ID of the table friend. So it's a friend ID. That's just name standard.
For me,
Or name.
if I have a table with different relationships to other tables, if I see something like friend ID, I think it's for a table called friend. But since this is a friend table, it's just a friend ID, I get slightly confused.
Yeah, but it all depends. I kind of do it like this, because if I have 40 columns called ID in my database, they all reside in different tables. Yeah.
But it's always ID of this.
So you have a personnummer. Yes?
Yes.
I would call it just a number because you are a person.
Well, yeah, but it actually has a specific name.
Yeah, it's just a number
Sure.
for a person. Yeah, so that's just naming standards or naming conventions. It doesn't matter how you are doing it. If you are doing it in a team, do it in the same way. Yeah. Why I like to use the table name as the prefix, so to say, for the ID column in the table is just because I kind of tend to like it. If you're thinking like this, if I have another table as well, where I tie this friend ID to something else, I would call it friend ID in that table, but ID in this table, by your logic. But with my logic, I would call the column friend ID in both tables. It's how I do it. As I said, what I'm doing is not right or wrong. It's just how I do it. As long as you can justify why you are doing what you are doing, it's okay. And if you are working in team, that you all work with the same rules. Yes. So I just wanted to show you that we got a table here with a column that is a primary key, and it has an integer as the data type. I usually see stuff like this, and they are using unique identifiers. Yeah, you are totally silent, but you probably seen that we have a data type, a GUID we can use, and that data type is called unique identifier in the database. Yeah, so why don't I like GUIDs? Because they are random. I like integers and the identity function because you have just one direction of the data. So you don't mess up indexes. So if you are using unique identifiers, you actually get a new unique identifier that is either bigger, larger, or smaller than the previous ones. That means that it ends up somewhere. And by using a symmetric data type and a symmetric function that always gives you a higher number, you always know that the new number is in the end of the line. So by doing that, you actually tend to not fragmentate your physical data that much. But we are going to talk about that stuff, because it's that stuff that is the important stuff in this session. And I call this session a session, and you can call it whatever you want, but I call it a session. And it's somewhere between 1 hour and something more. We have all the time until 8, I think. We can probably be here in the morning as well and talk about this stuff, but yeah. So we get this data model, and I actually had a small little tool in the back here where I actually didn't have a capture, but I'd like to show you what happens behind the hood when we actually are creating the database. And I just started Profiler. Profiler actually captures all the things that happens on the SQL server. And right now I have a trace here that captures T-SQL replay. That means it captures everything that is started and finished. I'm going to delete my database. Whoa, I deleted the database. So when I delete the database, actually I have a batch that is doing drop database. That's cool. So now I don't have a database, and I'm actually going to debug my application again, so we actually get the database built up, just to show you the code behind. And as I understand, I need to start the thingy as well. Yeah, so we saw it happened some stuff in the background here. we have a create database statement. This is perfect T-SQL. The stuff I don't see here is the really important stuff about data files and log files and file growths. But I see a perfect T-SQL statement. The bad thing I don't see here, I don't see a semicolon in the end. It would be awesome to have semicolons in the end as well, because that's part of the ANSI standard. And it will be mandatory in future versions of SQL Server. But I guess you guys knew that already. Then I see a create table. Well, that's totally beautiful as well. It says create table and the schema and the table name and the columns and the data types and if it's nullable or not nullable. It says identity, and an identity is a function that actually is a counter, and it's tied to the actual table itself, so it always keeps track of the highest number. And by default, it always starts at 1 and increment with 1. But you can do other mumbo-jumbo with that as well. The data type integer here, yeah, as stuff is going on in the background. The integer here is 4 bytes. If I've been using a unique identifier, it would be in 16 bytes. So that's the difference between an integer and a unique identifier. The integer, as it starts at 1 and just increment, gives me room for 2 billion friends. So if 2 billion rows is okay for me, I would say an integer is a better data type as a primary key of a table than a unique identifier. Okay, the unique identifier is 128-bit, so it supports a few more friends. Okay? But as that data type is 4 times larger, it consumes space, unnecessary space. And as the unique identifier also is random, either higher or lower than the previous ones, the unique identifier fragments the data. Then we see the nvarchar max. That means actually that everyone can have a name up to 2 gigabytes long names. That's awesome. But I don't think that's necessary as well. And we also support national, that means like Unicode characters, and that takes space as well. So when we are typing nvarchar max, it means 2 gigabytes of data, but 1 billion characters. If we go by varchar instead, that's also varchar max. It's also 2 gigabytes of data, but it's 2 billion characters. So a character is in Unicode 2 byte or more, depending on collation. So if we are doing like kana sensitive and in Japanese characters is the correct word. It consumes 4 bytes for every single character. Varchar will only consume 1 byte per character, so that means it consumes less data. The variable part generates overhead on the table as well. Null generates overhead on the table as well. So nullability and variable length might be consuming data space. I'm going to freeze this dude here so it doesn't jump around. Going back to this one again. Then you see something called constraint, and then the constraint is called pk_dbu.friend, which is the name of the table with the prefix of pk, stands for primary key, and every table should have a primary key. And this primary key will also be a clustered index, and a clustered index is actually a physical form of a table. So when we are creating a table, this table will be a heap, unless we are creating a clustered index. In that case, the table will be a clustered index. And this means that rows are clustered in something called data pages based on the clustering index key, which is the column friend ID in this case. So it actually will physically put a row in a specific data page. So if we have a unique identifier, that means that this row might end up somewhere, and the next row will end up somewhere. So this means that if we get full pages on the disk, it means that it needs to split this page into 2 pages and then store the row. That will give us bad performance. Okay? So it generates a few tables. And it actually inserts some data as well. Yeah, if I scroll up and down here, we're going to find more inserts for the friend table as well when it generates the 2 friends. And going back to the code part, I'm going to stop the debugger. I might even going to close. I'm sorry, I'm totally blind here, but that's okay. So when we are creating these models, this is like the database design part. We are telling the entity framework to create a table. We also have, I'm going to find the right one here, the data access layer part, where we create the friends content and an initializer. The context builder here is the part that actually creates the database and creates the tables. And when we are creating this table, we can actually configure our columns and the data types. So here I changed the data type for string columns to varchar instead of nvarchar. So this is where I, as a developer, can control this. I can set the max length. I can do the nullability part. So this means that every string is of the data type varchar. They support the length up to 100 characters, and they are not null. They require data. So this means that my friend Urk wouldn't be able to be created. Then I'm using the pluralizing table name convention thingy. So by doing this and then rebuild the application, it's going to make sure that I don't have a connection in the database. So my friend Urk is gone now, hopefully. I'm going to try to create this friend again with just the first name, see how that goes. And it crashes. Yes? Makes sense? Perfect. So now I'm going to stop the debugger. You see, I'm not a developer guy. You probably have some shortcuts and stuff. So I'm really proud of just being able to start the debugger. And when I start this one up again and press friends here, let's see if I got this dude anyways. No, I didn't get the dude. And if we look at the database now, we see that we could control the data types of the columns. So this is really important. And I'm going to explain you why this is important. So when we're looking at SQL Server, it's a relational database management system, one of many. It's the best. We have 2014 as the current version right now. We are getting 2016 in just a few weeks. I don't remember if it was 1st of July or 1st of June. It's awesome. And it has awesome features. And one awesome feature I'm going to talk about and show you is the in-memory OLTP. Have you heard about in-memory OLTP? So do everyone know what a relational database is? Yes. It's where we create tables, and these tables has columns, yes? And then we can have relations between columns. Between columns in different tables or between columns in the same table. Yeah, of course, we can have a parent-child relationship. And that's enforced as described as a relation between two columns in the same table. Yeah. In-memory OLTP needs a bit explanation. OLTP, online transactional processing, that's the normal way of interacting with data in the database from an application point of view. When we are doing bulk loading of data, we are not doing traditional OLTP interactions. It's when we are populating forms or having a point of sale application or whatever that do small interactions with the database and sends data to the database and persist the data in the database. OLAP is the opposite. That's when we are consuming large amounts of data in a database. OLAP stands for Online Analytical Processing. And that reads large chunks of data and processes large chunks of data to smaller sets of data so we can consume and understand the data. So OLTP is the normal way of interacting with the database. A relational database is built on this concept of a type of object called table and another sub-object called column, which is the field where we populate data, and relations, constraints between that describes how we can work with data. In-memory OLTP is a 100% in-memory relational database engine, and that's totally included into SQL Server. And it's really, really fast. So I'm going to talk a bit about that one. And why? Because we can actually use in-memory OLTP tables beneath the entity model. But for doing that, we actually need to manually changing the objects without changing the entity model. Physically, a database consists of data files and log files. A data file is where the data is persisted. So when we are creating a table, that's just a logical object. And when we are storing a row, we actually are storing a row into a data page which is dedicated for this table. A data page is 8 kilobytes, so that means that we have a limited amount of space within a data page. So a physical row cannot exceed the size of one data page, but the data page can contain multiple rows. And when we are designing the physical layer of the database, we want to store as many rows as possible in one single data page, because one page is one I/O operation. So if you don't have all the data up in RAM, we need to fetch the data from the disk. So when we are fetching the data, we want to have the least amount of work and most amount of data. That's common sense. So by controlling the data model, we can actually make sure that we can store more rows in the data page than if we're not controlling the data model. These pages are then grouped into a logical block called extent. And these extents can be uniform, mixed, or empty. Empty means that this is 8 data pages that is just allocated for storage. Mixed means that these pages are data pages that is allocated to different storage objects. That means we might have 3 data pages that is for that table, and 3 data pages that is for that table, and 2 data pages that is empty. That's a mixed extent. A uniform extent means that all these 8 data pages is actually owned by that specific table. So if we have a really fragmented database, we will have a data file that consists of many mixed extents. That's fragmentation. If we have a non-fragmented database, we have a data file consisting of many uniform extents. The really important thing with this is if we have uniform extents, SQL Server can do read-ahead operations, and it can do scans. If it's mixed pages, it needs to do seeks. So we have either non-sequential I/O or sequential I/O. If we have non-sequential or random I/O, we have a really low IOPS if it's a mechanical disk, and we might have a really high IOPS if we have an SSD. If we have sequential data and we're doing sequential scans of data, it's always faster. On a mechanical disk, it can be like 100, 200 times faster with a scan, with sequential reads instead of non-sequential reads. On an SSD, it might be 10% faster with a scan. And it all comes down to the SSD itself. The reason with the pages and the extents is also this thing. Have you heard that you need to format your volume where you store your data files in a specific set? When you are creating the partition, you need to set something called allocation unit size. Yeah, you need to set the allocation unit size to 64 kilobyte, because 64 kilobyte is the amount of space we need for one extent. So if we have uniform extents and allocation size of 64 kilobytes, we will have one I/O operation for retrieving one uniform extent, and that means 64 kilobytes of data in one movement. Yes? So if we have a really fragmented data, and we are reading data in 64K blocks from the disk, we actually are abusing the cache, and we are polluting the cache and so on. But if we have control of the data and the data is not fragmented, we actually are pre-populating the cache and making the page cache for SQL Server page buffers really, really beautiful, because we put the data we are needing up in RAM all the time. Yes? So that's how that is combined. So the data is always stored in the data file. Then we have a log file, and the log file is always there. We cannot turn it off, and it's for storing the transactions we are doing. So when we are inserting data in the database, or updating data, or deleting data, we are writing data in the log file and the transaction itself. In a compressed manner, but still we are writing the stuff there. And then we have a process called checkpoint. So pretty much once per minute, it will scan the transaction log to find open transactions that is committed, and if you have a committed transaction, it's going to write it into the data file. So the thing is, when SQL is working with data, when we are doing an insert, an update, or an delete, we have a process that actually retrieves the query and builds a query plan. This query plan consists of the method of how to do the work. This is then translated over to a storage engine execution plan, where the server gonna fetch specific parts of data. So the first thing it will do is checking if the data is up in cache for the SQL Server. If it's not in cache, it's gonna read it up in cache. So if we have an empty table, this table will have one data page. So when we are doing an insert, SQL Server is going to look in RAM. Do I have this empty data page up in cache? No. Read the empty data page up in cache. Then create a new version of that data page with a row. Then it's going to store both the old empty data page and the new data page with one row in the transaction log, together with the statement of doing an insert. Yes? And then it will auto-commit this row, telling to the RAM, yes, now I added this row. So it's going to throw the empty data page, the old data page away, and keep the new data page up in RAM. So this is what happened in a transaction. Outside of the process, outside of what we experience as logs and stuff, we have the process of checkpoint. So SQL Server will, pretty much once per minute, check the transaction log if we have a committed transaction. And if we have a committed transaction, it's going to read that transaction and write that transaction in the data file. So this means if we have a power outage, we don't have the data in the data file, It's gone from RAM, but it's documented in the transaction log. So what we can do with the transaction log is setting the database in full recovery model, which is default, and this means that we have a fully logged operation. And we need to maintain the transaction log by doing transaction log backups to empty out the transaction log. Have you ever seen a database with a data file of this size and a transaction log that is this big? And it just continues to grow. And then you have a DBA that says, yeah, but we do backups of the database. So it should be emptied. But they forgot about doing transaction log backups. Because it's a transaction log backup that's actually emptying out the transaction log. Yes. So we have this process. It's like a wheel. It goes round and round and round and round. We do changes, SQL Server checks in RAM. Do we have the data pages where these changes are supposed to be occurring? In RAM? No. Read them up in RAM. Do the changes on them up in RAM. Store the old version and the new version of that data page in the transaction log. So if we have a loop, so think about this, 100,000 lines of data. So if we are iterating through that set of data and insert row by row by row by row, we are first creating one row in an empty page. Then we're adding a row to a page with one page. So we are going to have multiple thousands of pages in RAM that is like nested to each other. And all these versions of pages will be stored in the transaction log. So we will have 100,000 lines. That would be 200,000 data pages. Okay? And just let's say that we can fit 100 rows in one data page. So that means that we only need 1,000 data pages in the data file. Yes? But we will have 200,000 versions of those data pages in the transaction log. And that's how SQL Server works. If we were to insert this data instead as a bulk, we can send a set of data to SQL Server. And in that case, it will locate those pages it needs to update and only store the new versions of them. So it would only generate 1,000 or 2,000 pages in the transaction log instead. So that's the biggest difference. And that's the problem with Entity Framework. If we are doing bulk loads through an object relation mapper, we are actually getting these iterations. Okay, with Entity Framework 4, we can actually send sets. We can do insert this table values, a set of values, comma, a new set of values, comma, a new set of values. We can set the batch size. And that might do this loading a bit better. But think about sending a statement containing 100,000 lines of code that is actually code, not data. That's silly. It would be better to just send raw data to the database server and let the database server iterate through the data. By doing so, we're going to shave away a bit of the overhead. If we look at the logical objects in the database, because a database itself is just a logical object. It's a logical container for storing data in a retrievable manner. We store the data by creating tables. And the table is a logical object which is defined of its columns, which has names and data types, and describes how data is stored on one row. A table can be one of two physical forms. Either the table is a heap. That means that this table is just a table without a clustered index. That's a really funny definition. A heap is a table without a clustered index. And a clustered index is a table that is a clustered index. That didn't even make even more sense, less sense. So a table can either be a heap, which is we store rows just randomly. Wherever space is, we store the row. So this means that data is just stored down. It's fast to store data in a heap because it just needs to find an empty data page to store this row, or a data page that actually contains space enough for storing a row. If we have a clustered index of this table, we have a physical rule that drives this specific row to a specific data page, and that takes a bit more time. So when we are inserting bulk of data, many rows, it's better to have a heap. Yeah? But we usually don't load bulk of data into an OLTP database because in that case it's not an OLTP database. So when we are having an OLTP database, we are adding a few lines. So if we have an overhead, when we are storing 5 to 10 rows, it doesn't matter. It matters if it's 10,000 rows or if it's 100,000 rows. The overhead per row ending up on one specific data page, it might be a problem. Yes? So if we have an OLTP system that we sometimes load bulks of data, we usually load this data in a controlled manner, like once per day or once per week or once per month. We load a bulk set of data. In that case, having a clustered index is not a problem because in that case we just need to find when to load the data so it doesn't interfere with other production. If we randomly store data in bulk, suddenly, during the best hour ever in sales, someone loads a huge set of data poof, straight into the production environment. That sounds like a really rare thing. If you have that need, you can actually use in-memory OLTP to make that faster. Or having a staging database where you bulk load the data into and then do some mumbo jumbo so the data gets nice and beautiful, and then you insert it in smaller batches. But that's loading of data. That's not OLTP. Yep. So a table is either a heap or a clustered index. So with that said, how many clustered indexes can I have on one table? This is a question that you answer on. Yeah, you want to answer, or did you just answer one?
Just one.
Just one, yes. We can only have one physical amount of data. So if we need to search data based on other columns, we need to add other non-clustered indexes. A non-clustered index is perfect for seeking small sets of data. A clustered index is awesome for finding bulk sets of data. So the default, when we are creating a table and having a column as a primary key, and having a clustered index based on that primary key, you know the only simple reason why that's good. If the only reason for fetching data in this database is based on a row based on the ID, or if it fetches bulk sets of rows based on the ID. So if we fetch all the customers between 1 and 10,000, that's an awesome index. But we rarely fetch customers based on the primary key column when we are talking about sets of customers. So that means that we might need to have another column or set of columns that defines the clustered index. So for example, if I travel around in the world and I have my friends in that database where I have a first name, last name, city, and country, maybe the best clustered index for that table is probably country and city. Because in that case, all my friends in one city is physically stored close to each other. Yes? Makes sense? So how many of you have the clustered index on a table based on the primary key column? Raise your hand. Have you ever thought about this before? So that means that I'm saying something that might be a bit interesting. Okay, cool. Yeah, so when we are searching if I create a non-clustered index based on country and city, I probably will not use that index if I want to find all my friends in a specific city, because it would take too long to fetch all the unique IDs of people in a specific city and then do those seeks in the clustered index. Yes?
So, for example, you create a table and you have an index on the ID, but then you also set an index on, say, the country.
Yes?
Maybe that's an ID to another table. That's not a clustered index.
No.
Those are two indexes.
Yes?
Yeah.
So probably I will have the clustered index based on the person ID. Or in this case, I'm going to switch over to the... I think we are going to have a short break as well. So if we are looking at this table, right now my rows are physically organized based on the ID. So if I create another index based on country and city, so I easily can find all my friends in a specific city. That means that that index on country and city would be a non-clustered index. And it would contain the clustered index key. So it would give me a list of clustered index keys or primary keys where people who live in a specific city exist. And then I could seek through the clustered index to find all these people. It would be like a huge loop. And actually the process, if it would perform it, would be a nested loop. Make sense? It could do like this: fetch all the IDs of people, create a list of these IDs, sort them from low to high in an ascending order, and then do a merge join to the clustered index, because the clustered index is sorted on the ID. But that would generate a scan of the clustered index.
So the clustered index, it's like setting up a key to a dictionary made up of two things.
Yes.
Two separate indexes is like two separate dictionaries.
Yes. I'm going to see if I can have the... Okay. So I didn't get a black screen. I'm going to try it again. So. It's blue. So our table, like this, has its columns. Yes? So we got the column 1, column 2, and so on. Really beautiful. I'm going to try to use my finger. So this means that we have a row that has a size. This row is stored in a data page. So if we have 10 million rows, and let's say we can fetch store 100 rows in every data page. Yes? This would mean that the average size would be something around 80 bytes per row, because 80 times 100 is 8,000. The space in a data page is 8 kilobytes, minus some overhead, which is metadata for the page. So that means that we have 8,060 bytes of row storage. So that would mean that we will have a database that consists of 100,000 pages, yes? Where rows are just stored randomly. So if you are creating a clustered index, it will generate a new set of pages. So it will pretty much do select star from table, order by primary key in this case. Yes? And it would store all these 100,000 pages, but in a sorted way. So we would have in the first page 1 to 100, 101 to 200, and so on, until the last one with 10 million. Yes? So this is the data pages of the data itself in a sorted manner. Then it would read the first line of every page and store them in a new set of pages on top of it, which pointers. So it would say, on the first line, it would say 1. On the second one, it would say 101. So I would have like an index of where are the data stored. And then it would, on top of that, read the first one and create a new set of pages all the way up until you only get one page in the top. So you get like a pyramid of pages with pointers. And this part would be the clustered index. Yes? So if I'm searching for anyone with a specific friend ID in this case, my friend, and I'm searching for friend ID 13, and my table is a heap, yes? I actually need to read all the lines because I don't have an index. Even if I find 13 on the first row, I need to read all the other lines as well because it might be another line with 13. So every time I search in the data and my table is a heap and I don't have any indexes, I need to read every single line. So that's why we create indexes. As the table can have the physical form, either heap or clustered index, the clustered index is one kind of an index. And the clustered index is a cluster because we cluster rows in pages. And we cluster the rows based on the column we are driving the clustered index on. In this case, friend ID, which is an integer that is ascending. Okay? So we cluster the first 100 rows in the first page, the second 100 rows in the second page, the third 100 rows in the third page, and so on. So this means that the first row in the first page is the lowest ID. The first row in the second page is always higher than the IDs in the first page. That's why I can read the first line from everyone and have an index. If I'm searching for something that is between, or let's say I'm searching for 13, and the first one is 1, I'm going to look at this index. Okay, 13 is greater or equal to 1. That means that 13 is probably available. Then it goes to the second line in the index. It says 13 is greater than 101. No, that means that 13 is probably in the first page. And by that I can seek one page. Instead of reading all 100,000 pages, I can read one page. Is that faster? Yes. Even if I have an overhead of reading 3-4 pages to realize that I only need to read one data page. Say I need to, it's 3 levels. Yes? Yeah, 3 levels for as an overhead for fetching this page instead of reading all 100,000 pages is still much better. But this index is always only awesome for finding these uniques based on the primary key or finding a range. So if I want to have all my friends with a friend ID between 1 and 10,000, I can use this index to do a scan. So I can start to scan over here and stop there. Because if I'm fetching friend IDs that is bigger than the ID I set as the max, I don't need to read any more pages. So I will have partial scans of the data. Is a partial scan faster if it retrieves the rows I need instead of a full scan? Yes. So having a clustered index on the primary key, is that useful? Yes, if I'm only fetching one row at a time. If that's the only thing I'm doing, that's awesome. But if I'm fetching my friends in a specific city, I'd like to have a clustered index based on the city column instead. If that's the primary way of me fetching a reasonable amount of rows. And when I say a reasonable amount of rows, I'm thinking about pages and extents and physical I/O. So let's say we can store 100 friends per data page, and the extent is 8 data pages. That means that we store 800 friends in one physical I/O operation. Yes? So if I can have the overhead of fetching 800 friends every time I fetch something, because I probably will want to have another friend as well in the same city. If that's feasible for me, having a clustered index on the city column is much, much better. And that's why I have a lot of work, because you usually see clustered indexes just based on the primary key, unless you have a DBA driving the indexing. And in that case, the indexes might be strange, or we might have a lot of indexes. Yes?
I'm just curious, if you have a clustered index on, say, city, but it's a varchar,
Yes?
I mean, here it works nicely to deal with integers, so you can just work your way up. So is there anything special going on? Does this go by like the encoding, what that exactly is?
Yeah, so the question was, so in this case, my index key is an integer, so it's really symmetric and nice, and it's always just ascending. Could it, if we are using a city instead, what would that be? How would that be? Because it would be in varchar in that case, and that would be a string that is somewhere between 0 or 100 characters in this case. Yeah, so as long as I never change the size of the value in a specific field, so if a person never moves from one city to another city, and I only insert data in this table, and I always insert data in an ascending manner, I would not fragment the data. So probably I would have a more fragmented physical table. So I would need to rebuild the index more often. So when I'm building this index, I need to think about the thing called fill factor. Fill factor is a feature we set on an index to make sure that we save space in the data page for new rows. The default is 0, which means 100%. That means that we fill the data page when we are rebuilding the index. And that means that we don't have more space in the data file, in the data page. So when we are adding a row that belongs to that page, we need to split that page into 2 new pages. Yes?
Generally, in that situation, is it best practice to pull that city into another table and then just use ints?
Yes and no. Yeah. So when I do this talk, actually, I'm talking a bit about normalizing. So we're going to end up in answering these questions really soon. So when we have this clustered index, we can actually delete this because the clustered index contains the data. It's the physical rows. It was a select star from table. Yes? A non-clustered index only contains the non-clustered index key and the clustered index key. So it only contains a pointer to the physical data. What I can do with a non-clustered index is actually include columns. So I can say that this non-clustered index includes also these 2 columns. And by doing so, that would create a sub-table of the table, a copy of a part of the table. And an index like that could actually be really, really helpful if I'm fetching data based on different orders. So if I need to fetch all my friends' first names when I'm searching for city, I could include the first name in that index. And by so, I could have a scan of the non-clustered index only and not reading the physical row. So in that case, I would have a supporting index. And that's really awesome. Those indexes are built like this. Select non-clustered index key, comma, clustered index key, comma, included columns from table ordered by non-clustered index key. And that would create a subtable of just those specific columns. That's the good thing with Camtasia, actually, that it actually keeps Zoomit thingies. I'm going to jump back to the slides again. So index is really important. That's the key of performance. If we have small databases, small tables, a few set of rows, just have a clustered index based on the primary key and keep it like that. If you have issues of fetching data fast enough, you need to think about what would actually be the most feasible clustered index. We have other objects as well in the database, and we have something called a view. A view is actually just a named query. We can write the query, select these columns from this table, order by this, and so on, where this is true. And then we can name that query as a view, and then we can reference the view as the view were a table. So when we are referencing the view, it actually executes the query within the view. Okay, why is this important? Yeah, it's really important if we are doing a remodel of the database to support the entity framework. We have something called a function. A function in SQL is some kind of formula or expression we want to execute. For example, validating a personnummer. For example, doing the modulus 10 calculation and so on, and to make sure that the control cifra in the personnummer is correct. And that your gender is correct, and so on. We are gender neutral, so we might just translate the 9th digit in the personnummer to null. Or pi. Yes, but we can create functions, and those doesn't do any changes of data. It only performs a calculation. So it would be like a method, but a method can do changes when we are talking about object-oriented programming. Yeah, but we have functions as well. But when we're talking about, yeah, so a function is just for capturing formulas and making calculations easier. A procedure is for capturing data access logic for changes. So if I have a really normalized data structure, I might have problems doing an insert of my business object, because that means that I need to add data to 48 tables. If that model is right or wrong, I don't know, it all depends, but it's really strange to have something like that, at least if you are working with entity framework, because in that case you just created this entity and you want to store this data. But if you have complex logic when you are inserting business objects, that could be like, yeah, we are doing an insert with this XML document, which is an order. And then we let the procedure parse these XML and put the order header data in the order header table and put the order row data in the order row tables. So for storing that kind of logic, that data access logic, we are using procedures. A trigger is a procedure-like object that we tie on a table or a view for after insert, update, or delete, or instead of insert, update, and delete. So when we're talking about entity models and a SQL database, what I usually recommend is, first of all, let the developer work with code first and create whatever data model he wants and have it persisted in a database. What I then recommend everyone is doing is creating views for every table. One view per table, or actually one view per entity. Change the name of the table to something else and change the name of the view to the name of the table that supports the entity model. So by doing that, I'm creating an access object or proxy object in the database that supports the entity, but I'm disconnecting the table from the entity. I'm going to try to do it like this, black, and do yellow, yes. So we have our object that is stored in an entity. Yes? This one generates a table in our database. What I'm creating in the database is a view that fetches that data. Then I change the name of the table in the view, so the entity points to the view instead. So this means that the view can always represent the table. We can actually support insert, updates, and deletes through the view if you want to, as long as the view only works with one table. And the data in the presented from the view is raw data, not aggregated data. Okay? What I also like to do is generating methods, insert, update, and delete methods in the entity model. So I'm generating 3 procedures from the entity framework per entity. So I will get these procedures. So instead of doing having those automatically created insert statements from entity framework down to SQL Server, I'm getting store procedure calls. The cool thing when I'm doing this is me as a developer doing code first can actually name these procedures in the database. And the code needed for doing the insert, updates, and deletes are actually captured within those procedures. Okay? And by that, I have the insert, update, and delete operations as well in the table. And I've actually disconnected the table from the entity model. Does it sound doable? What would this mean if I change data platform from Microsoft SQL Server to Oracle? Would it fail? No, it would create these procedures in Oracle as well, based on Oracle code. Usually when you say that you are using an object relation mapper that do this automatic thingy, it's like my code becomes platform independent. Have you heard that? Yes. Procedures are not platform specific. It doesn't matter if you are running on Oracle or MySQL or Microsoft SQL Server or Postgre or DB2 or whatever. You are invoking procedures identically in all these different platforms. Identically. The call is identical. If you are doing the custom insert, updates, and deletes, the code are platform specific. Yes?
Does that mean you still get to use the syntax that you get, for example, when you set up one of these mappings with Entity Framework, for example, when you want to say you insert something, you add one of the Entity Framework models to the table, and then you do, I can't remember what the method name is, but you say you do database changes.
Yes.
I'm not familiar with this. Is this insert, update, these methods you mentioned here, are they sort of overrides that they then get called underneath?
Yes.
Okay.
Yeah. So Entity Framework actually supports this to generate these procedures. You don't need to create the procedures. You just say, tell Entity Framework, create these procedures. And everything occurs automatically beneath.
And then creates them on the server.
And creates them on the server. So that means that you can create the Entity Framework model. You can actually generate the database with the tables and the proxy objects. Hand that over to me. What I can do is changing the names of the tables and creating the views. Then I can change the content of the procedure. So I'm going to show you this stuff because I know, have you guys been using procedures from Entity Framework before? No one? Just a few. So I'm just jumping away from this stuff. So like this, and we are jumping over here. Just look at the database here. We can see that we don't have any procedures right now. I'm not going to do inserts without procedures and showing you the code because we are going to see the exact code the Entity Framework generates in the procedures we get. So instead of tracing and so on, just to save time. Yes, I want to close it. It's like doing those exams, you know, you get the question, do you not want to do this? So I'm jumping back here again into the context builder, and as I said, I'm going to share this code, so you can look at this code. If you have questions about this code, you can probably ask me, because I can probably answer on these specifics, but if you are talking about Visual Studio stuff, you should ask someone else. So I'm like all those chefs. I actually, instead of me trying to type this, so what I need to do is use the method, correct me if I'm wrong, map to store procedures. I call the, initialize an object as well that I call S in this case. Is that correct? You are learning me object-oriented programming, so that's why I'm here. But on this procedure, I'm saying that the name is add friend, because that's like really logical method of an method on a class of friends for me. The procedure name add friend and the parameters that I need to add. The mod friend, it could be change friend or whatever friend, but I choose to use mod because it's 3 characters. And the IDs that I need to supply when I'm executing the procedure, or the columns, and the delete based on the ID. Because when I'm deleting one at a time. Yes? If I have bulk needs, I can create procedures that has a table as the in parameter. Then I can create in .NET, execute this procedure and populate the parameter, which is a table, with this set. Then I can have set-based bulk operation on the SQL server side. But I'm not going to show you that part because I cannot do the C# stuff by hand. So this is 3 simple procedures. I think this is doable for every single developer to create. You can probably have this generated automatically as well if you are creative of reading your entity model. That's my guess. So I have these 3 procedures, and I'm just going to debug it again. I was about to say execute my application, but that's wrong because I'm debugging, right? And just to make sure I don't have any unnecessary locks. If I've been really smart, I probably had, what's it called? Saved and rebuilt, but I think it rebuilds automatically when I do debug, yes? And saves as well. Yeah, so I'm saving time. Yeah. Jump back over here again, do a refresh. So we see we have the same table again, and we have the columns configured as we wanted. And there we got the procedures created automatically. And if we are looking at the insert procedure, we see it creates some code. So the first thing it does when it inserts a row, it do an insert statement. And then it declares a variable for the ID. Then it do a select on the table. If the row count is larger than 0, row count always gets a number for every single operation that occurs. And the friend ID is equal to scope identity, which is a function that fetches the last generated identity for that specific table in this set, in this execution scope. Yes, so it reads the table of reading the data we just created. Then it generates a new select to fetch the friend ID from the table based on row count larger than 0, and the friend ID is. Does this make sense? It's like, in my world, it's a bit silly. If I were to create a procedure for doing this stuff, I would do this. So this is why you as a developer don't need to care actually about the code. I would do that. Then I would do this. Because I will probably do something more as well. Do some logging or whatever. Then I would just end this with by doing so. So this means that I insert a row, I capture the identity, and then I return the identity to the entity framework. So this is actually what the entity framework should have done from the beginning. But it doesn't. It do a lot of silly reads. And it do these silly reads because it doesn't know if you get another ID generated for some other user. So it actually needs to fetch the row it created to make sure it actually created the row. Yes? And if you are doing this really SQL-wise, we would actually like to have like this, begin tran, commit tran, and we would like to capture this in a try. Begin try, and try, begin, catch. I'm gonna copy that one because I'm lazy, and I copied something else. It's the nice tool I have installed in my. And in this catch, I can do the rollback. For example. And right now, I just wrote some pseudocode. I should actually put in more beautiful transaction handling and change checking before I do a rollback. It's depending on where between the begin tran and commit tran the error occurs. But that's probably a better procedure than the previous procedure. Okay? You guys don't need to think about this. You are just creating these proxy objects, and then you give this as a mission to the database developers. So how many of you have projects where you are developing stuff and you are more than one person in this project, and you actually have a dedicated database architect or database developer? Raise of hands. Yeah, one hand. How many projects should actually have a dedicated database architect / database developer person? Every single project. Why is this important for consultancy business? Because if everyone says to the open market that every project needs to have a database architect or a database developer, I get more work. I mean, we can probably make sure that the data model we are implementing is better and more overall perfect for the specific application and for the customer need than just the database built ad hoc based on code first. I've been doing too much work of trying to fix problems. And when I end up in these projects where we have these big performance issues, like a bank having all these gazillion rows shoveling into a database with like 2,000 tables. And yeah, I'm just doing an extreme example with like 4011. Yeah, I didn't say 5011, so 4011 different applications working with this database. And I see, yeah, but we need to normalize this data. We need to break this table into 5 different tables. I'm going to break 4011 applications. This needs to be changed. Or I'm not possible doing this change. So if we are creating these procedures, what me as a dev guy, a database developer, are going to do is renaming the table, creating a view with the name of a table, then creating instead of trigger on the view for invoking these procedures. So if you are doing something directly to the table, because it's the view, you can do an insert, update, delete on the view, and it invokes the procedures. So you still have the data access logic in place. And you have disconnected the table from the object model, which is what I need to optimize. Because if I come to a platform built like that, and I see, okay, this table should actually be broken down into 5 different tables. The database contains all the information I need. I can normalize this table. I can find the dependencies to the procedures and the view. I can update the procedures and the view. I don't need to change a single bit on the application side. I don't need to do a recompile and a new test of the application. The only thing I need to test is that the view is delivering the same thing as the table we're delivering. Yes? And that the procedures are invoked in the same manner, do the same logical change, and deliver the same result. So I don't need to test anything else. So I can isolate the database optimization just within the database environment. Wouldn't that be awesome? Of course, I need to do more tests and do regression testing and that, so on. But the effect of the change is really, really isolated to just a small set of objects. And even if the database and the table needs to be normalized, I can have a view that is flattened. If we are looking at the delete statement, it's really, really simple. It's just doing a delete. It doesn't return anything. And the modify, or the update, is just doing an update. It doesn't return anything. So the insert, which is doing the simplest thing, is doing more pseudo logic, which is totally unnecessary. That's funny. In earlier versions of Entity Framework, every single row was always a select, an insert, update, or delete, and a select again. And that was really, really silly. So what I can do here, I can rename this table. I can do it graphically if I not know how to write code. Now the table is changed. I need to update these ones. That's the del. The alter. I'm going to remove this part so I don't create a silly thing. Execute that one. And I need to check this. I need to check them because I just closed some of them. It was this one I forgot. Like that. And then we are doing this. And schema is something really, really good. Schema is like a container, but it's not a container. You can use a schema to group database objects together and then use this to imply security based on membership in the schema. So the tables, the procedures, the functions, the views, and so on in a schema, in the same schema, can inherit the permissions assigned to the schema. So I have now a query that returns all the data I need. So this is the view I need.
Should it be friend?
Yes, of course. I was just testing you. So now I changed the database. And I have the application up and running. I'm going to press details for Carl Hamilton. You see it works. And I'm going back to the list and I'm going to add another friend who it's 2 minutes left, and it still works. I haven't recompiled anything. I just changed the objects in the database. The bad thing now is, if I change the entity, I will have it recreated. So the modifications is gone. So that's the downside of just going code first all the way through. So in this case, you need to change the update model property in the context builder. Okay, did you get this? Is this usable? Something that you could use? Yeah. Would this ease problems in the future when you get performance issues in your database? Maybe, maybe not. So with this said, when we build our databases, we have this logical and we have a physical module. And we actually have a logical module and the logical physical model and the physical logic model and the physical model. So the entity model is logical. The database is logical physical from the application point of view. But from the database, the DBA guy, the database is also a logical model. And the physical is how rows are stored in data files and how we are retrieving data and indexing. That's physical model. Okay? So this is usually creating some kind of fussiness between developers and database guys when we are talking about data models and how to implement everything. It's usually some kind of debate and a fight, and the DBA is always losing. Usually the DBA is always losing. When we are defining a data model, we have the question about, okay, if I'm using just integers, so I'm usually doing having another session called database modeling, pretty much, where we have this kind of set of data, where we have this flat data, and we are normalizing it. So we are breaking this down into persons on streets, in cities, in countries, and so on. And we have a table for every single logic object, because a city is a logical object, a street is an object, which is actually part of a city, and a person is living on the street, and so on. And by that, generating relations between these tables. So we have a street ID that is a primary key for a street, and we assign the street ID in the foreign key column street ID on the person. Yes? So creating this normalized structure. Having that from .NET and working with data in that manner from .NET is like hell. Is that true or false?
It's true.
It's true, yes. So if you have models like that, you like procedures. That is like add person, and you have a procedure with the parameter for first name, last name, city, street, and so on. So you can invoke just the procedure. So by using Entity Framework and creating a highly normalized data model, that's like super silly. So when we are designing the data model from Entity Framework, we are normalizing based on common sense from a developer point of view and business objects. Yes? If we are creating these proxy objects in between, like the views and procedures, we can have a database architect or a database administrator or a database specialist or database something that can optimize the physical model, which is the tables from the application point of view, and what the procedures are doing, and normalizing. I'm going to use another presentation as we ended up, it's 8. I hope we are not just chased out. It's okay. If you want to leave, as some has already done, please do so. I'm going to Google myself. I'm going to add PDF as well. But it's me, yeah. There, this PDF. So this was from a really, really old presentation, but it always shows up when I'm when I need it. But it's about normalization. It's about a lot of performance stuff and so on as well. It was actually the first time I was talking about LINQ for SQL and LINQ for entities in public. I was talking about that when I was doing the session. But when I started the session, I was like, okay, do everyone know that 100% of the performance issues based in SQL Server is due to the developers? And one guy raised his hand and said, do you know that all of us in this room is developers? So in that case, I just sket i det blåa skåpet, as we would say in Swedish. But my response was, yeah, let me prove it. Yeah. So anyways, I'm having this simple table looking pretty much like the same stuff we had with the friends. We have a context table. And think about, we are storing context to all our friends in Sweden. We are 10 million people in Sweden. So if you have a table structure like this, and if we just think like varchar 50, yeah, that's a variable length. And the average length would be something around 6 characters, 7 characters or so. But if we are doing calculations, we can say that every string is 50 bytes. Otherwise, it will be really, really messy calculating. I have actually done wrong here. So it should say, if we are looking at this physical row, we will have a 4-byte header for the row itself, making sure that we know that this row is the specific row in this data page. Then we would have the fixed length column. Integer is always 4 bytes, so that's a fixed length column. Char6 is a fixed length column, it's always 6 characters. Varchar 50 is variable length, so we need to have a variable header, so making sure that we know if we have variable length columns or not in this table and how many, and a variable trail that makes sure that per each variable column that makes sure that we know the length of every single variable length string. And then the variable data. So we would have a physical row that would be somewhere between 28 and 238 bytes per row. I forgot one variable pointer when I did this calculation. So the physical row would be somewhere between 28 and 238 bytes. That's one row. So if we are thinking about rubber bands, it would be a really flexible rubber band. So how many rubber bands can we fit in a row, in a page? If it's like somewhere between this. Yeah. So if we are saying that every row is 238 bytes per row, we are going to have like 34 rows per page. So if we have 10 million rows, we can calculate that we need 294,000 something data pages, and this table would be somewhere around 2.3 gigabytes. Yes? In reality, with real data, with your names and addresses and so on, it went 712 megabytes, this data structure. But that was the full population of Sweden, with real names, not funny make-up names. It was, I had a database. Yeah. But in theory, worst case scenario, if every string is 50 bytes, it would be 2.3 gigs. So just by breaking this down into 3 logical objects like person, street, and city, will the physical size be lower? Yes or no? Yes. How much? Yeah, we're going to shave off pretty much a third. So it would be somewhere around 1.3 gigs if every string is. What this became with real data, I don't remember that size, but it's somewhere around 400 or 500, because it didn't get that really much smaller with the real data. Based on, we don't have as many cities as we have persons. I didn't need to type Stockholm 2 million times. I could reuse Stockholm 1,999,999 times. So the risk for me misspelling Stockholm went really, really small. So if we are looking at this data, this is a logical NF3. But I would say that like this is not NF3. If we are looking at this, is there a difference between a first name or a last name? Someone says yes, and maybe someone says no. Yeah, I would say no, because it's just a string. Is it a difference between a first name or a city name? Actually, no. It's just a string. It's just how we use the string. You can have the name Virginia. You can live in Virginia. Yes, it's just strings. It's just in the context of using the string that says it's the first name or a last name. So if we are doing a reference table that is just containing all the unique strings, I was thinking like this. So how many first names, last names, and so on would we have? So I was just doing estimate. Okay, let's say we have 50,000 first names, 50,000 last names, 50,000 street names, and 50,000 city names. And then we add 50,000 names more. So we have 250,000 different names. I think that would be okay for Sweden. I think that's a bit in the upper limit as well. So if you do a reference table containing this 250,000 unique names, and then instead of storing the name in these tables, just storing the ID for the specific name, what would that, yes?
Just wondering what considerations when someone gets married, when you update.
Oh, yeah. So when you are updating a name, you are just changing one integer to another integer. Would that be hard? Yeah. So by doing so, that is actually based on the worst case scenario that every single string is 50 bytes. So if we can remove 2 gigabytes of the 2.3 gigabyte table, would that be good?
Probably not.
No, that would probably be really, really bad. So by doing this, we are actually shrinking the data down to pretty much 14%. As a reference, the names table, if every name would be 50 bytes, would be 16 megabytes in size. 16 megabytes. Yes?
I think space is cheap, right?
Yes, space is cheap. It depends on where. Space on disk is cheap. But when we are working with data from a database server, where is the data then? In RAM. So if I can store 7 times as much data in RAM for the same cost, would that be good? Would that do changes to performance? That would be good. Yes?
It's a trade-off though, because say for example, if everything's denormalized and you need to update a row, you can just change out the string. But say for example, if a married example, you need to go and define that big table of names to figure out what ID to change to. So then it kind of shifts the cost, and ideally it'll
Yeah.
work out better in the end.
You always need to balance it back and forth, back and forth. But finding a string in a table consisting of two columns, which actually can have a clustered index based on the ID and a unique non-clustered index on the name. And that unique non-clustered index would actually contain all the data in the table as well. So you would have two physical forms of the same data sorted in the ID form and in the name form. So would it be a really, really high cost to finding the unique ID for a specific name in that case?
I'm sure, I don't know enough. I haven't used SQL.
Yeah, I would say no. No. Because if you store the string, like if your last name is Ek and you are getting married with someone called Jonsered, Jonsered doesn't fit in your physical row. So you need to create a new row where you enter yourself in the database. So by doing that change, it would create a bit more problem. Yes?
Now that memory is cheap, why would I need it?
Yeah, because you maybe have more friends than I. It all depends. Everything depends. Think about it like this. What you could do, because this name table in reality would be somewhere around 4 or 5 megabytes. So when the client application starts, when the application starts, it could cache this name table and hold it in RAM at the application side. And the only interaction we have about the name table is if we add a name that is non-existing. Otherwise, we are just using it in RAM on the client side. And we only read this data one time when we start the application. So if you don't need to do the round trip to the database for that, and when you are working with the business data, the persons on the streets and so on, you only ship the integers back and forth over the network. You are saving network space as well. But yeah, RAM is cheap. What is cheap? It all depends. I would say if you are having a web application on some kind of web hoster, you don't have that much RAM. You are usually limited in RAM, how much RAM and how much CPU you can consume and so on. So you need to be conservative anyways. And if you take it on the other way, the reason why I'm doing coding stuff right now, I'm not doing C++, but close to. I'm doing some IoT stuff and so on. So when we have just 64 kilobytes of RAM in our small little device here, space is of concern. Did that answer your question?
Yes, I think so.
Yeah. So anyways, by doing this, we are creating a hotspot, the name table. But if you are thinking about this, if we can shrink the amount of data down to 14%, what about just reproduce the names tables into a few more tables? Just duplicate that table and removing that as a hotspot. Otherwise, it could be a locking problem. That table, you only need to do inserts and selects against. You never do updates or deletes to the name table unless you want to purge unused names. So you never do an update of a name. You update a person's name by changing one integer to another integer. That means that these individuals, streets, and city tables are perfectly symmetrical. We always know that one single row is 30 bytes, no more, no less. So this means when we change from Ek to Jonsered, we change one integer to another integer. So the row never needs to be moved anywhere. Make sense? I'm not saying that this is the best way of doing it every time. I'm just using this as an example data that everyone can relate to. And maybe using some of this in reality. But this is what normalization is. So the first step was when we broke it down into 3 objects. That's normalizing. Then I generalized data. I said a name is a name. So I generalized data. But we will have a really messy data structure, so we could denormalize it to make it a bit more easy to work with. So by pushing these three tables together into one table again, it will be bigger. So it goes from 300 something to 400 something megabytes in size. But this would be easier to work with. Yes or no? Yeah, a bit easier. So what I did here is denormalizing the data. It's called a database because we are storing data. We are not storing objects. So when we are doing the normalization dance, we are normalizing the data. We are not normalizing the objects. That's how I think about it. It's a bit nerdy, geeky. I might be unique in that way. But by doing this, it actually gives you better performance. It gives you an easy way of doing IntelliSense for your applications, because you can consume the real strings in an easy way and cache that on the application. But having an entity model working with data like this, that would be really, really silly. Yes?
Couldn't you sort of take your 4 tables you had previously and just make a view out of context, or would you
Yes.
sort of lose space on that? Or is that
Yeah.
the idea?
Yeah, of course. I could actually keep it like this and have a view on top of it that actually puts it into this shape. Of course. So it's all up to you how you want to do it. I just wanted to have like the 3 different steps to describe them. Yeah. So I actually got challenged by a guy working with really big data sets and this model, and he said, I'm going to prove you wrong. And he spent the full weekend of actually proving himself wrong. And I was like, yes! It actually fitted his scenario perfectly. And he actually got pretty much 200 times better performance in their database by just doing this. From my side, it was just pure luck. It fitted his needs perfectly. But it was like really, yes. Because he was like totally, after the weekend. I would probably not go this far on this because data space is rather cheap. But if you put it in all the different layers and where it can be used and so on, space can be expensive. Space is expensive when we are talking about disk. Not in storage, but in performance. Yeah, but the performance I solved by doing SSDs. Yeah, but if you have a better normalized data structure, it will perform even better on SSDs. I'm jumping back to the original slide here again. Symmetric and predictable. I like data in my database to be symmetric and predictable. Symmetric in the way that I know the sizes of my rows. I doesn't get something like it's huge suddenly. If I want to store large objects in my database, I have features called file stream or file tables. So if I want to store pictures, high-resolution photos in my database, I can do that. I would not use the data type image because that would be stupid. I would use a feature called file stream and having it controlled by the database but stored in the NTFS file system. I would not store it in the file system and store a path to the file in the database. I would create a column of the data type var binary max. Then I would add a file stream file group to this table and map this var binary max column to the file stream. So when I'm storing this large object, it will be streamed as a file in the file system. And it will have pointers internally in the database. And when I'm doing a backup of that database, I'm actually taking a backup of the file storage as well. And that's an awesome feature. So if you are doing that, storing large objects in databases, look at something called file stream. It's awesome.
If you're using integrated security, you need to use
Yeah, if you are not using Windows authentication in your solutions, you are doing something wrong.
So that you can.
Now, I would say like this, name me an operating system or a client or whatever that cannot use Windows authentication.
Yeah, you can, but you might not be allowed to.
Why not?
Well, it depends on the situation.
Arbitrary open source.
Yeah, so what? You have an application probably because you are not consuming the data directly. You are going through an application. This application can, in this case, be executed in a host environment that still is running Windows authentication,
Well, yeah,
Kerberos authentication, but the consumer of the application doesn't need to be Windows authenticated.
true, but it might not be up to me to decide if I can use it or not.
Yeah, it's your job to explain for the customer why it's really, really important.
True, maybe.
Yeah.
But it still might not be
Yeah,
allowed.
of course, there are discrepancies. It's not always black and white. We have somewhere in between that is gray, and in the reality, the gray part is really, really big, and we need to shrink that gray part. Windows authentications would work in 99.9% of the cases. That 0.1%, we might manage it in a different way. But in the majority of the ways, we can do Windows authentication or Kerberos authentication. So performance, I put up performance and security here. But by doing this, we are actually performance enabling. We are not doing performance optimization when we are adding procedures. Procedures is just an abstraction layer for the methods of doing changes of the data in tables. It's a performance enabler because I can do performance optimization without changing the application. So that's why I call it a performance enabler. It's really a security mechanism. Security in a way of making sure that the right data ends up in the right place. And we can also use these access objects like the views and procedures to making sure that the right person is filtered on a row-based level to just the data this person is allowed to touch. Yeah? So it's an awesome security feature as well. And together with Windows authentication, getting row-level security, it's really, really awesome. And when I'm saying security, what I'm doing is giving the users select permissions to the views. And I'm giving them execute permissions to the procedures. And I'm not giving them any permissions at all to the tables. Because they don't need to access the tables, they need to access the logical objects in the database. Yeah? So by that, I actually ensure information security in the database as well. That is not doable in another way. Yeah, you can encrypt rows and so on and decrypt them, but in that case, you lose performance because you cannot index that data perfectly. Yeah? So with that said, in-memory OLTP, an awesome feature, we got it in SQL Server 2014 Enterprise. We are not storing rows in pages. We are just storing rows. When we are changing data, we are not updating rows, we are creating new versions of rows. And this only occurs up in RAM, and it's persisted by streaming the changes down to the file system. The other big benefit with this is we don't have any locks. We don't need to lock data because the rows are versioned. And if we are changing data, the old version of the row is still available. So we will not have any locking problems. It's really awesome. If we have two persons changing the same row, and you get the merge conflict, the last one on the bucket is the guy who is getting a slap. I need to do a redo. So it's perfect. This feature is using FileStream to stream the data down to the file system, and it's really, really fast. We have minimal logging, because it only logs the operation and the row ID. The row is streamed into the file system, but it's kept in RAM. And when we restart this database, it reads the data stream up in RAM and only keeps the last versions of rows in that case. It has a purge process and garbage collection and so on during normal life. That is really, really awesome. The downside is it requires RAM. So if you are going to have an 1 terabyte big table, you are going to need pretty much like 2 terabytes of RAM. So that is probably not like the perfect scenario. But if you have these smaller sets of data that you have extreme high performance needs on, you can have them memory in RAM, like an old TP table. It's pretty much the same create table statement, but you add a few features. You are saying that this table is persisted in RAM. Indexes of this table is only up in RAM. First of all, you need to have a unique hash index for every row. So that's done on the primary key. And if you need to have search indexes, they are also hash indexes based on the search terms, mapping to pages in RAM. And it's really, really fast. The project name was Hackathon, and that means like 100 times. And that was the goal, having it 100 times faster than disk-based tables. And it's not 100 times faster than SSD, but it's like 10 to 20 times faster than SSD, yes.
So would you recommend that we would use only memory for the databases for now on, if we have enough memory space?
I would say like this, those hotspot tables, where we have concurrency issues and so on, when we have like hotspots, and we have a lot of changes, I would say in memory would be probably the best choice, yes.
Why not all?
Because, yeah, because I'm working with databases that are like 20, 40, 200 terabytes large. And in that case, having 400 terabytes of RAM would be a challenge, actually. Yeah. And if you are looking at those small databases, yeah, of course. The downside is actually the word enterprise. Yeah, so if you have a database need that actually requires the enterprise features all over, you can use in memory. Yeah. And in that case, you usually have big databases. That means that you will not overconsume the RAM by having all the data up in RAM. You only need to have the data that you are working with in RAM. So that means those hotspot tables or those always used tables. Yes?
Because now it's very popular, the microservices architecture, meaning that each domain is completely isolated. So all databases tend to be smaller and smaller.
Yeah.
So maybe that could be a great scenario for just start using it if we have enterprise license.
Yeah, but that is for just a small piece of the business. We still have these ERP systems and so on. So if you have an ERP, you don't want to have the full database up in RAM. You probably only want to have parts of the data up in RAM. Yeah, like Navision and that mumbo jumbo kind of. That's still there, yes.
Sorry for asking so many questions, but imagine that I start with putting everything in memory. Can I easily switch not to be in memory anymore if I start getting without memory space?
Yes, so I'm not going to create an in-memory table right now. I'm just going to, first of all, generate the create statement of this friends table. Oh yeah, I need to refresh first so it goes to the right object. And to the query editor window, of course. Yeah, so I'm going to remove some parts here. This we don't need. So this is pretty much a create statement of a normal table. I'm not going to create an in-memory table. I'm just going to right-click here to get the syntax of creating memory optimized table. So in the database, we need to have a file group for memory optimized data. This is actually a folder where it streams the rows. Then we need to enable, so a file group, which is a logical pointer to where to store the data, and then we need to add the file to that file group. Then we are creating a table. So this is the table. So we have the name. Then we have a column name. Like that. Oh, the right character. So we are defining columns in the same way, but we need to create a constraint, a primary key constraint, for this column. Like that. It needs to be an identity. It cannot be used based on sequence, because sequence requires disk access. So this doesn't use disk access. This can actually consume the data from RAM. If you want to have an hash index for something, you are creating that index hash based on this column, and then you add something called a bucket count, which is a number for the discrete number of unique values in that column, times 2. So if you are going to store 1 million rows, you would say it's a bucket count of 2 million. It's really, really crucial, because when we are creating this table, it actually generates those buckets in RAM, but empty. So if we need to extend the size of the table, we actually need to drop and recreate the table, and with 2060 we might not need to do that. I haven't checked that part, if we actually got the alter feature. Then we are saying that the table is memory optimized equals on. This is a memory optimized table. And then we say durability equals schema and data. And this means that every row is physically persisted on disk within the transaction. So this is a memory optimized persisted table. If we want to have a temporary table but in RAM, we can say durability schema only. And this means that it only stores the row up in RAM, and if we reboot the server, we flush the table. And that will be an extremely fast table, but it will be empty every time we restart the database. But it could be a good scenario that as well. So that is the changes we have on the create statement. We need to have this hash index, we have the bucket count, and we have the with memory optimized and durability part. That's all. Nothing more, nothing less. And the really cool thing with this is, this will be a C object.
What does it mean?
Yeah, it actually creates a C struct, and when the database gets mounted, it executes the C object, or whatever it would be called when it's C. Struct maybe. Yeah. And if we are creating procedures, we can say that this procedure is natively compiled, which means that the procedure will get, pretty much like C# goes to MSIL, the T-SQL will become a C struct. And that will also live in the same memory space as the C struct of the table. And it will not be like .NET CLR, which needs the virtual host, the guest running for executing the code. It will be running when the database is on. So if all that gets turned down to really, really slick C code, would it be fast? Does in-memory OLTP sounds awesome? Yes,
This sounds too good to be true.
it requires enterprise.
So what's the catch? Is there something that you're not
Yeah, the only catch is you need an enterprise edition SQL server. Yeah, so you need to have a SQL server that is licensed by course. And you buy the startup with 4 cores, and it's like 120,000 Swedish or something. Then you upgrade that license if you need more than 4 cores. So if your machine has 16 cores, you need to have 16 core licenses, and that will be a really, really expensive SQL server. Yeah, so if you spend like $500,000, $1 million in licenses, you probably have a lot of RAM, but you cannot probably buy 2 terabytes of RAM because you spent a lot of money on licenses. Yeah, this is really, really long session. I'm sorry for that one. So actually, it's really easy to translate this into in memory. Just a few words on the create statement. But the Entity Framework cannot do it. We need to do that as a database developer. Yes?
Can I still use views? So if I would have the model that you proposed, all the views are in front of it, and behind the scenes to change everything into in-memory database. And from the
Yeah, in theory you can do that, yes. As long as that view only interacts with in-memory objects. Otherwise you will lose performance. So you don't want to always do joins between an in-memory and on-disk table. If you can work only in memory, you get awesome performance. If you need to combine in-memory data with on-disk data, you need to think about how you bring that data together. The thing is, if you have a database already up and running, and you want to see if you could feasibly be used in memory, there are actually a set of, I think it's on Codeplex, that you can download an extension for Management Studio that actually can analyze a database and identify targets for in-memory. I'm telling you, this and this would be awesome to have in memory based on the reality, how people are using the data. So you actually don't even need to think, you can just do. I like that stuff because sometimes it's not like that in reality, so someone needs to fix it. Yeah. So it's actually really simple. It was a new feature in 2014, and it's even better in 2016 that we get in a few weeks. But that's changes you can do on the database side. And when you are doing those changes, you don't need to change anything in the application code. It's totally transparent. So I would say it's an awesome feature. There might be some videos on Channel 9 and YouTube showing how to set it up and do so. I might have a demo as well that I could run some other day, but doing another extra thing would be like bad because it's like 20 to 9 right now. Did you believe that it's 2040? That I've been talking for 2 hours and 40 minutes. When I say it like that, it's like, oh man, what am I doing here? So what I would like to say is we always need to use common sense because we should not do everything just because we can. We should look at the need we have and identify where the pain points are in our solution when we need to do changes. I totally love heavily normalized data models, but in reality we don't need to do it. What we need to do is creating those proxy objects in between. So if we actually need to do changes, we can do the changes without having a super change in our application, and 6 months later we might have a performance improvement. So we would like to have the database as agile as the .NET environment is. And by using these proxy objects in between and using Entity Framework, we can actually create it. We just need to create the proxy objects in between. And that's fairly simple. Even I could do it. Yeah, so doing that in Visual Studio and in the C# part. The benefits is if we are identifying these points and we actually have the possibility of doing the change without having that as a major change of the application. If it's just a small minor thingy, we can have it within just a patch as a minor update. And it would be easier to implement improvements in the database. The challenge is if we are doing like this, disconnecting the data, the table module from the logical model, and we need to change the logical model. We need to have more supporting objects in the database. So that would mean that if we have this person table, and then we realize that we also need to have personnummer because that's a business key, not the primary key. If we are adding a column that is requiring data on a table containing a lot of rows, it might take 4 days to add that column. So in that case, we might need to add another table containing personnummer. Yes? And that would be a patch. Then, when we are doing a major update of this application, we merge those data structures together. Does that make sense? To change a logical data model when we are doing a major update, it requires that we have a good documentation in place, probably. Because it's kind of hard if you have a lot of ad hoc coding done, finding all those bits and pieces that are related to each other. But on the other hand, we have testers, so they might find it for us. And enjoy doing it. Yeah.
One thing I don't really understand yet is worth doing all this with views and procedures?
Yes.
If you're starting from the ground and you don't really know how your database is going to look yet.
No, I would say it like this. When you are starting green fresh on something and you're not sure about the full model, you're doing your developing stuff, doing code first. In a few months, you as a team has decided on this is the model. Yeah. And by that you say, okay, now we are at the point when we can do a version of the data model. Make sense? Yeah. I'm not saying it's the best way. I'm not saying it's the worst way either. It's just one extra way of doing it. Yes?
So basically, if we implement the procedures, one benefit is instead of sending SQL statements, we are just sending the data and the name of the procedure.
Yes. Yeah. We are minimizing the amount of data sent back and forth between the application, and we are also putting control in those that actually know how the database works when we are trying to solve an issue. Otherwise, we need to capture the traffic generated from Entity Framework, identify that this was the thingy that we got this problem with, and trying to nest through how this automagic feature of Entity Framework actually are working, and how we can prevent it, an issue. Having a procedure, the issue is either how to invoke the procedure itself, but that's fairly easy because that's just execute this procedure with this input. Or it's based on the logic within the procedure. And in that case, it should not be something that is changing something in the application. In that case, it's something wrong in the database itself, and in that case, it just needs to be corrected. We should never put business logic in the database. And that's usually what we see in procedures, and it's usually what people believe when we say we should have procedures. They should be simple, and they should only capture simple things. And business logic is kept in the business layer. And I bet most of us agree on that part. Because SQL Server is not good at enforcing business rules. And if we are changing database platform from SQL Server to whatever SQL it might be, or NoSQL, we're not sure that that platform can support doing these business rules thingies. So that's why the application should work with the business rules. And I think I have that demo part that we talked through. So the conclusion is Entity Framework adds possibilities. We get more options of doing things even better. And a full abstraction layer, which Entity Framework is, should also consist with supporting database objects. And the supporting database objects is the views, is the procedures. Because the entity model needs the other side as well, so we disconnect application from tables. Yeah. And if we have extreme needs, we can actually go all the way through in-memory OLTP. But we should not normalize data because we can normalize it. We should only normalize data that we need to normalize. And if we don't need how to do it, to know how we need it tomorrow, today, yeah, we seldom know about the future, but sometimes we do. But if we don't, why should we normalize data? In that case, normalizing from a business point of view is based on logical business objects. It might be smarter to have an address table and a person table and an organization table, for example, and having relations between these objects. It doesn't make sense to have a string table containing strings. That is something that is optimizing that we might do in the future. Would I normalize all my friends tables or similar kind of tables in that way I showed you in the PDF thingy? No. It wouldn't make any sense. I would make sure when I'm creating the basic data model that I have a proxy object between the table and the consumer. That's the view and the procedures. So if I need to do the changes, I can do the changes, and I also know by that also what objects I need to update. And use the common sense. Tack. So this was 1 hour. I hope you liked it.